Hey you guys, this is Mr. Sal. Thanks for watching. This is just a review of the 10.2 homework from 7th grade. Mean, median, and mode stuff. So thanks for watching. Don't forget to comment, like, and subscribe below. Alright, here we go. Find the mean of the following data sets. Alright, so let's go ahead and add all these together. So after adding all these together, we get 39 divided by 8 because there's 8 numbers. So I got a 4.875 on that one, just by finding the mean. The next one we'll do the same. Let's add these together. So we got 132 when we add those, and how many numbers do we have? So 132 divided by 10 gives us a mean of 13.2 on number 2. So let's find the median of these following data sets. Let's list them in order from least to greatest first. Alright, now that we got that settled, so we go on the first to last, the next person last, and we'll just work our way inside, and we can see the middle number right here is 6. The next one as well, let's go ahead and put these in order, and they even gave us a decimal on this one, which appears to be the lowest of the numbers. Alright, so we got the first and the last cancel, and then the next first and last, and we'll just move our way inside. And we got these two numbers right here. So we're going to add them together. 11 plus 8, divide them by 2, and we got a 9.5 would be the median for these. Survey was conducted where respondents gave their favorite summer temperature in Fahrenheit. The results are shown as follows. Find the mean temperature from the survey, and then we'll round to the nearest degree. So we need to add all of these together. So we got 1027 when we add all those together. Then we'll divide it by. So we got 14 total numbers. We'll divide them. So rounded, this was rounded to the 100th, but it says to round to the nearest degree, so that would just be 73 degrees.
Yep.
20 males and 20 females were asked to approximate the number of times that they viewed Facebook each day. Histograms for the data are shown below. Based on those that were surveyed, which group had a greater median, the boys or the girls? Explain your answer. Now, we should be able to look at this pretty quickly and determine that. The females are more spread out, so the median should be somewhere in the middle. It's more than likely. Whereas the males, there's a lot more values on the left side of that. So we would expect probably the median to be somewhere in this range right here. Well, let's go ahead and figure out how we would find those medians. Alright, for example, it shows us in these histograms how many values were for 0 to 3, 4 to 7, 8 to 11, and so forth. So for example, that one right there kind of cancels out this one right here. And then this one would cancel out the next one, the next highest one. Just the same thing we were doing as if we had a list, right? The low right here cancels out the high. And then we got this low, which will cancel out this high.
Why?
This low cancels this one, because we're just trying to find the center right here, that's all. Or the middle. And then this one cancels these. This one cancels this one right here. This one cancels this, and we're left with this value and this value in the middle, which means the median should be right in between those, 3.5-ish. On the next one, though, for the females, same idea. These 3 will cancel out these 3. These 2 cancel out 2 of these, and then this one cancels out this one. And then these 3 will cancel out these 3, and we can see that the 2 in the middle are in the 8 to 11 range. So the greater median will be with the girls, and we can explain the answers just by showing the work here by finding the middle value for both. Why would mode not be a good measure of center for the female data distribution? That is because the mode is more of a shape kind of thing, which we can see in these two graphs, not a measure of center. It's not a really good measure of center anyways. All right, we got these two dot plots, and we got to make them according to these two rules. We got rule number 1 for dot plot 1 here on the left. It must have a larger spread. So that means that we need a larger spread. So from the smallest value to the biggest value, we want them to be more spread apart, which will give us a greater spread or range. So I could go into this and say that my minimum value down here is something like 10 with a maximum value of something like 200 up in here. What? Just to spread these out far apart. Now the dot plot number 2 must have a greater measure of center. Oh, by the way, dot plot 1, I want values on both of those to give it a larger spread. But dot plot number 2, I need a greater measure of center. So if I put more values here closer to 10 on dot plot number 1, then I just need dot plot number 2 to have more values closer, well, bigger than somewhere in this range. Because right here, smack in the middle, something like that, would be, I don't know, 105-ish, right there. So if we make the measure of center on dot plot number 2 to be somewhere in the 150s, and we're good. So we can have a smaller range or spread by making this 100 to 200, so now it has a smaller spread. And right smack in the middle is the 150, right? So I just need more values to be higher rated over here. Something like this. And this would give us a higher measure of center for dot plot number 2, which is slightly emphasized. And dot plot number 1 has a greater measure of greater spread though. All right, here's the second part. Ms. Parrish gave her students a math test and recorded their scores. Following is the data for all 16 students in her class. Find the following values. We'll find the mean, median, and mode. Here we go. So we'll start with the mean by adding all the values together. So I got a sum of 1208. I'm going to divide it by the 16 students. So the mean score was 75.5. And of course, to find the median, it'd be helpful, even the mode, it'd be helpful to list these in order from least to greatest. All right, so this is a list from least to greatest. So let's go ahead and take a moment to find the middle. So I got least greatest, least greatest, least greatest, just work my way in the middle. Least greatest, least greatest, least greatest. So it looks like it's going to be between 84 and 85. So 84.5, very good. This is the one that occurs the most oftenest, which appears to be 91 and 98. Have 2 values each. And also 0 right there, right? The 2 scores that are listed as zeros are from students who were absent. Recalculate the measures of center without the zeros. Alright, so that just means we're going to get rid of these 2. Which, as it turns out, is not going to affect the sum. It's just going to change, instead of using 16 values, we're now going to use 1208 added together, but now it's 14 values. And the median should move over just a little bit. Let's go ahead and check on that. So we got 75 and 98, 77, 98, just working our way in the middle. And we see it's between 85 and 86, so 85.5. And the mode, instead of including 0 now, is just going to have the 91 and 98. All right. Explain the effect that the zeros had on the mean and which values provide the better indication of the center with respect to the student scores. Well, it definitely changed the mean quite a bit, because before the mean was 75.5, but it increased the mean by over 10 points. So, all right, that was just the mean though. So in this case, we would kind of anticipate that Well, we may notice as well, it didn't affect the median too much. So we could say that the median would be a better measure of center or better represent the scores. Or we could even use the mean just without the 2 zeros. It just depends on how you look at it. Students tried out for the school play by memorizing a part. The students were rated on how well they performed and how much they were able to memorize. The ratings were scored on a scale from 0 to 100. The scores for the 20 students are shown. Well, let's sort this data from smallest to largest. All right, we'll start with the smallest. They didn't really help us with this, but it looks like it's 14. All right, so that is organized the data from least to greatest. All right, let's find the following values then. Let's go ahead and add all these together. So the sum of all these numbers. All right, good. So we got the sum now. Let's divide it by, there were 20 numbers is what it said. So we'll divide it by 20. So we got the mean at 82.9. But let's go ahead and find the median then. So we'll start with least and greatest, and just keep working our way inside. So yeah, we got the two 88s right in the middle up in count. Right count. So we'll add the two together, divide by 2, 88. Alright, the mode on this, there were 4 88s. There weren't 4 of any other number, so 88 also is the mode. The first student on the list got a 6 stomach during the tryouts and couldn't finish. So only scored a 14. The student was allowed to try again later that day and scores a 99. So we're going to go in and replace that 14 with 99. Alright, so let's go ahead and find the new mean score. So to do that, we can just take the 1658, subtract the 14, and then add 99. So the new sum is 1743. And we still have 20 values. So let's go ahead and divide that up. Alright, so we got that. How did the mean score change? Well, it improved by almost 5 points. About 4.5 points, which is pretty good for the mean, if we're looking at the averages. So it did change. It went up by almost 5 points. Hamlet is calculating the new mean instead of replacing the redo score of 99. Hamlet adds the redo score to the end of the list, then divides the sum by 20. What is the result of Hamlet's calculation? Alright, so we're going to go back to 1658, add 99, and that would give us 1757. And then following what they said, he divided that by 20. So that gives us... So yeah, by adding that score, he should have divided by 21, but it said he divided by 20, and that means he would have gotten 87.65. Bam. Now notice it didn't really change that much for the actual adding of the 99. So his calculation wasn't really the average because he should have divided by 21. So that's what he should do. He should divide by 21 instead of 20. Thomas and Enrique run 2 miles every week and record their times in minutes. Their data is recorded in the table below. Which runner has data showing the greatest spread? Explain using the plots and comparing data points. So the spread, we're just looking at the maximum and minimums. So Thomas has a minimum rather, 15 to 20, which gives him a spread of 5. Enrique has a minimum of 13 with a maximum of 23, so that gives him a spread of 10. So Enrique has a greater spread by 5. Alright, then which runner has the fastest mean time? So we'll start with Thomas. So let's add all his together. So we're going to take 15 plus these two 16s, 17, 18, and 20. So that's a sum of 102 for Tom. And we're going to divide it by 3 6 numbers. And then let's do Enrique. So we got the 2 13s, the 15, 17, 21, and 23. So Enrique has a sum of 102 just like Tom does. But Enrique has a 6 times. So that also will be 17. So as the fastest mean time, none of them do. What about the median? Well, let's check on those as well. So for Tom, we got the 15 and the 20, 16 and 18, 16 and 17. So Tom has a median of 16.5. And Enrique's median, we got the 2 13s, cancel the here. And so the difference between 15 and 17 is going to be the 16. 15 plus 17 divided by 2. So it appears that the fastest median will be with Tom. If you wanted to select one of these runners to represent your class in a running competition, which one would you choose?
Enrique. Tom.
It all depends. All depends on, so it's 2 miles every week. Enrique is certainly getting better, but they didn't tell us what order they have in it. Did he start with 13? Did he start with 23?
He started with 23.
But Thomas is a little bit more consistent with his times because he has a smaller spread. So you may choose Thomas and say, well, I'd rather go with someone I know about what their time will be. Whereas Enrique, we're not sure if he's going to run a 23 or a 13-minute 2-mile race.